All right, guys, welcome to another Vulkan API discussion here at CUDA Education. Um, Normally, I would carry you through the torture of drawing things out as we speak, but the video didn't work in the middle of me drawing it out, and I basically lost the video, so I have to do it over again, but I'm gonna do it over again with everything on display for you to see. Okay, so pipeline vertex input state. All right, let us say that in the pipeline vertex input state, it's basically dealing with describing data that you're handing to the Vulkan API. Okay, so for example, let's say you gave the Vulkan API a USB stick, right? And you just gave it to the Vulkan API. All right? So you just hand over a USB stick to the Vulkan API. You have your mask on, Vulkan API doesn't know who you are, and you just hand them a USB stick. You hand the Vulkan API a USB stick. Vulkan has no idea what's on the USB. There's no labeling on the USB stick itself. It's just a blob of data that you give to the Vulkan API. And you say, here, Vulkan API, here's a USB stick, and show me something on the screen in about 10 seconds. This is not going to work because Vulkan doesn't know what's on the USB stick. There's no guiding light. There's no information about what you're handing it. There's nothing. And that's what pipeline vertex input state is about. It's about handing over a piece of data to Vulkan, but then also making sure you describe what is, what the data has. All right? So instead of just handing a blank USB stick with, when I say blank, I mean, there's no labeling on the stick itself, and it's just a blob of data and it doesn't have any information or labeling or anything. What we do is we use the pipeline vertex input state to describe the data. Okay, so remember now, Vulkan works in graphics pipelines. So graphics pipelines is just a workflow or a series of logic that basically ends in displaying something on the screen that we could all see. That's what the pipeline is about. Okay. And what the pipeline does, it consumes data. So this data now, it might be an SSD on your hard drive, and of course, this is all managed initially by the CPU. So, you want to basically transfer this data over to the Vulkan API, which is sort of on the GPU, and process it appropriately. So the pipeline is going to receive data, but in order for you to properly receive the data, you have to describe what is on the data. Okay? So what this does is let's say the USB stick that you give to Vulkan API, it has 8 megabytes worth of data. On those 8 megabytes, you have location, it's split up into different, pieces. So you have location 0, 1, 2, 3, 4, 5, 6, 7. Now let's say, of course, these locations, each is 1 megabyte each, just for argument's sake, just to make it easy, right? So you have location 0, 1, 2, 3, 4, 5, 6, 7. 8 locations, 1 megabyte each. And it's now you have given Vulkan 8 megabytes worth of data. And now you've broken it up into different pieces. Okay? The binding description the binding description is concerned with the layout of the data. So high level layout, big picture, high level data. So it looks at the 8 megabytes, and then you tell Vulkan, hey Vulkan, location 0, 1, 2, 3 is for Vertex data. So binding 0 is associated with Vertex data. Location 4, 5, 6, and 7 is instance data. So binding 1, as we attach here, is for instance data. And I'll get into the two in a minute. Okay, so we now have a high level roadmap on what is on, for example, the USB stick that was handed to the Vulkan API. We know that location 0, 1, 2, 3 is Vertex data, 4, 5, 6, 7 is instance data. All right? And that's binding descriptions in a nutshell. Now, of course, the number of location and the sizes of each of the binding can change, and it can be variable, but just for this example, I just make it even and stuff for our purposes. So in the Vertex data, what is Vertex data? That is information about, coordinates, information related to Vertex information itself. So, like when you're doing a triangle or something, you have vertex, you have 3 vertices, right? So this might be the Vertex data. Instance data, in the example that I use in tutorial number 15, instance data relates to things that are related to per each instance in your pipeline or in your scene, right? So the example in tutorial number 15 is a planet in space with about 8,000 rocks surrounding the planet. The rocks themselves are rotating around the planet or circling the planet, and then the rocks themselves, each individual rock is also rotating. So the Vertex data might be the vertex mesh, the vertices of the creating the actual rock itself. So actually the structural mechanical vertices of the rock itself. Instance data deals with the texture of the rock, the color of the rock, the rotation of the rock, and the scale of the rock. Okay, so this is instance data, and then the Vertex data, of course, is again the mesh, the vertex mesh of the rock itself, right? So 2 different pieces of data. So that's why you have binding 0 for the Vertex stuff, binding 1 for the instance stuff, okay? Now, before we go on to attribute descriptions, one other thing. Notice that when we're actually doing the binding description and we say, okay, binding 0 is for Vertex information, in the binding description, we say per Vertex input rate. Per Vertex input rate. That means location 0, 1, 2, 3 is going to be consumed for every vertices that's in the pipeline or in the scene or what have you for this pipeline, right? So this data is consumed on a per vertex basis. Okay? Binding 1, 4, 5, 6, and 7, this stuff is instance data, and it's going to be consumed on a per instance rate. So for every instance, we're going to consume location 4, 5, 6, and 7 and apply it to each instance. Now, in the example that we work with, there are about 8,000 rocks that are circling the planet, right? 8,000 rocks circling the planet. So this piece of data right here is going to be applied 8,000 times for each of the instances. So for each of the rocks, you're going to apply texture, color, rotations, information, scale information, right? This is on a per instance basis. So that's why in the binding description, it's very important to not only declare that you have binding 0 and binding 1, but what kind of rate are you applying it? So this again is going to be applied per vertices. This is going to be applied per instance, right? And you need to make that distinction. We're kind of done with binding descriptions now. So, all right, let's forget about this piece right now. So right now we're dealing with binding 0. In binding 0, we have vertex data, as we have said, but then you have 1, 2, 3, 4 locations, location 0, 1, 2, and 3. So 4 locations that we now have a blob of data that we know is vertex data. But we have to be more specific. So attribute descriptions now is going to describe in each one of these locations exactly what is in this particular location. So, what is the format of the data? What is, I believe, the size of the data? But basically, what is the format of the data in each one of these cells? Okay? What is the format of the data for the vertex data? Same thing in binding one. So now we have a blob of data that's binding one and we know it's instance data. But I need you to describe to me 4, 5, 6, and 7. What is in each one of these? What is in each one of these are cells. So remember, instance data has rotation information, it has texture information, it has position, scale, all that information. So the data type and all that stuff for each one of these is going to be different depending on what location it is. And you describe that in the shader and all that stuff. I do that. I discuss it in more detail in tutorial 15. But again, the attribute description is probably the closest thing to your data, and it specifically describes what is in each one of these cells specifically, right? And it tells you, it communicates to you, VK format, R32, G32, and all this stuff, right? So it gets very specific about what is in each one of these locations, right? So again, binding description is a lay of the land. Attribute description is specifically what's in each location. You can't just have attribute descriptions alone. You can't just have binding descriptions alone. You need to have the two of them as part of the input state that is consumed into the pipeline creation process so that the pipeline knows exactly what it is dealing with. All right? So this whole idea of you're just gonna hand over a blank piece of a blank USB stick with no labeling, nothing on it, and it has 8 megabytes worth of data, it doesn't work, right? You actually need to describe what it is. You need to describe what it is you're handing to the Vulkan API. Right? So this pretty much is input state. And again, tutorial number 15 talks about this stuff in detail. And that's pretty much it. Pipeline, vertex, input state. That's all it is. Binding description, attribute description, and you're trying to communicate to Vulkan, what is the layout of the data you're handing it, and what is in each one of the locations that you're handing it. This location stuff is like within the shader that you declare and stuff. So there is the the vertex shader and the fragment shader and all that good stuff. But I don't want to get into that right now. But when you talk about input state and you see binding description and attribute description, this is kind of what you're tackling. And again, binding description, you have per vertex input rate and per instance input rate. Again, because you're trying to tell Vulkan how you apply this data, where you apply it, how you apply it, what things should be consuming these pieces of data. And that's pretty much it, guys. Again, tutorial number 15, I will have a link in the description below for tutorial number 15. We actually go through running code on your Windows-based machine with a Vulkan-capable graphics card. We actually, we go through the code and we see this stuff in code and it's running. Again, the example code that I use is courtesy of Sascha Willems, and he has a bunch of examples that is freely available. Tutorial number 13 is a video walkthrough. Tutorial number 13 is a video walkthrough on how to get all the examples running on your Windows-based machine with a Vulkan-capable GPU. But once you have, I really suggest you do tutorial number 13. Make sure you have the example running, and then you go through tutorial number 15, where you could see the code run and make changes as you wish to see how it affects the example. Again, the example is a planet in the middle in space, and then rocks that are circling the planet. The rocks is the instancing pipeline. So this pipeline here is the instancing pipeline, and the instancing pipeline consumes this data so that it knows how to build the rocks, and then it knows how to apply texture, color, rotation, scale to the rocks. All right, so it's a planet in the middle. The rocks circle the planet, right? But then the rocks themselves also rotate. So we have to tell the instancing pipeline, you know, how to build the rocks, how to rotate the rocks, how to, you know, what color and texture to apply to the rocks, all of that good stuff. And we have our per vertex and per instance input rate in order to deal with that. So I made a previous video on binding description and attribute descriptions, but I think this now is a little bit more clearer, and obviously it's sort of because I have a better understanding of how all of this works. So input state is very important. I know this stuff hasn't really been communicating too well on the internet. So we're not in the business of just handing over blank blobs of data to Vulkan. You actually have to tell it what it is you're handing. That's pretty much it, guys. CUDAeducation.com. Check out the website CUDAeducation.com. You know, tutorial 1, 2 through 12 deals with building a triangle, and you know, goes through that. Tutorial number 13 is installing a set of examples courtesy of Sasha Williams. I will link a description to his repository. I mean, you know, I'll put a link to his repository in the description below. It's on GitHub. But definitely tutorial number 15 goes through all of these steps in code so that you have a better understanding. All right, guys, that's it for now. Thank you for your time. Thanks for watching. Have a great day.